Today we're going to discuss about trigonometry. Trigonometry is a word that's been derived based off of two words, trigon, meaning triangle, and metron, meaning to measure. The trigonometric functions are functions of an angle that relate the angles of a triangle to the lengths of its sides. In this particular case, our triangle is triangle ABC, having the following sides: side A in small letter, side B in small letter, and side C in small letter. The first of the six trigonometric functions I would like to discuss with you is sine. Sine A, this right here pertains to the angle. Angle A is opposite over hypotenuse, meaning to say opposite right here over the hypotenuse C, which in this case our symbolism will be small letter A over small letter C. The next trigonometric function is the cosine, and in this case we're going to work with the angle A, and so cosine A is adjacent over hypotenuse, and in reference to this angle, the adjacent angle is this one right here, which is the B, and the hypotenuse is the C. Just a quick clarification regarding the word opposite and adjacent. In this particular case, let's look at the adjacent right here. Um, I understand that some of you may argue and say, well, B and C are both adjacent to A. That is true. Both of them are adjacent to A, but C has a special name, and it's not going to change the name. This is always going to be called the hypotenuse, making B become your adjacent. And again, this is in reference to angle A. So with angle A, your adjacent is this side B, and your hypotenuse will be this side C. Our third trigonometric function is the tangent, and again, this is in reference to tangent of angle A. Tangent is opposite over adjacent, so in reference to angle A's opposite side is this right here, which is A, and our adjacent to A once again is the B. Just clarification, once your theta or your angle changes to, let's say, angle B, then all these agreement right here or relationship right here would also change, because in reference to angle B, your adjacent now becomes A, and your opposite in reference to angle B is this side right here. Once again, speaking of adjacent, A and C are both adjacent to B, but C will never be called adjacent because it has a special name. And the special name of C is that it is always fixed to be your hypotenuse, being the side opposite the 90-degree angle. Therefore, this side right here is always going to be called your adjacent in reference to angle B right here. And this will always be the opposite in reference to angle B right here. Just for memorization purposes, we are going to use SOHCAHTOA. SOHCAHTOA is sine, which is opposite over hypotenuse, cosine, adjacent over hypotenuse, and TOA, tangent, opposite over adjacent. That will hopefully help you memorize the relationship between all these sides and angles. Being in Algebra 1, our focus will be on this three right here. However, I also want to show you all the other three more trigonometric functions. These are the abbreviation for their names. This is sine theta, and again, theta is your angle. In this particular case, our angle is A. Once again, this could become angle B, like what I said a while ago. So this now is just a general description of all your functions. So once again, sine theta, cosine theta, tangent theta, cotangent theta, secant theta, cosecant theta. So let me show you now that once again, sine theta is opposite over hypotenuse. It is very easy to remember these functions if you're going to take a look at them as opposites. So the sine theta, actually the opposite is cosecant theta, and this cosecant theta is if this is opposite over hypotenuse, then this is hypotenuse over the opposite side. Okay, now let's take a look at cosine theta and secant theta. They are again the opposite. So if this is adjacent over hypotenuse, your secant theta is going to be hypotenuse over adjacent. Okay, last but not the least, tangent theta and cotangent theta are opposites. And so if tangent theta is opposite over adjacent, cotangent theta is adjacent over the opposite. Once again, we are not going to use this three. We're going to use only sine, cosine, and tangent for the purposes of our discussion. Okay, let's have some examples. This example is wanting you to express as a fraction or decimals the following. So the first one is sine r. So this is your number one right here, sine r. And we know that sine is opposite over hypotenuse. So that's sine opposite over hypotenuse. So that's what we have. Let's look at angle r. In the case of angle R, the opposite to this angle is right here. That is 15. And the hypotenuse is 17. Therefore, we will go to our calculator. And we are going to get us a new document and type in 15 divided by 17. And that is let's go and make it into a decimal, and your answer is 0.88. So go back and you put in approximately, okay, 0.88. Example number 2, cosine r, and I had placed here your guide. So cosine is ka, which means cosine is adjacent over hypotenuse. So you have that there. In reference to angle r, your adjacent is side 8. So once again, I understand this side and this side are both adjacent to r. You're not gonna call this adjacent because that's hypotenuse. So this is what you're gonna call your adjacent. So that is 8 over 17. You're going to go to your calculator and divide by 17. You're going to transform this into a decimal, and your answer is 0.47. And you're going to come back here and put in approximately 0.47. So now let us do tangent r. So once again, this is your angle of reference right here, and your opposite is 15, and your adjacent is 8. So 15 out of 8, and you can get your calculator. 15 divided by 8, and you're going to change that to a decimal. Your answer is 1.86, 88, because you need to round. So this is approximately 1.88. Let's check that again. Yep, 1.88. Let us go ahead and do sine q. So this is your angle of reference. Sine q is opposite over hypotenuse. So that would be 8 over 17, which I think we got it here already, approximately equal to 0.47. And so let's keep on going and do cosine q. And cosine is ka, that is adjacent over hypotenuse. And in reference to angle q, your adjacent is the 15, and this is your hypotenuse. So that is going to be 15 over 17, which in this case, I think we've already calculated 15 over 17, and that is 0.88. 88. Right now, what we're doing is just we are just expressing this into ratios and fractions and decimals. That's all we're doing. So let's keep on going by doing the final one, which is tangent Q. And tangent Q is opposite over adjacent TOA. So from Q, your opposite is 8 and your adjacent is 15. So this is going to be opposite over adjacent. And your opposite is 8 out of 15. We're going to go here and do 8 divided by 15, and that is going to be changed to a decimal, which is 0.533, repeating. So this is approximately equal to 0.53, repeating.